October 29th, 2025. 3. Atlas reaches its perihelion. A NASA engineer detects an anomaly. The comet does something impossible. It moves strangely. Something is pushing it. And it's not gravity. 2 possible explanations. One natural, one technological. But there's also something else the scientists didn't expect. Something they saw while it was hidden behind the sun. And what the data shows makes no sense. The NASA discovery. If you've seen my previous videos about 3I/Atlas, you already know this comet was strange. But this is different. This comes directly from NASA data. On October 30th, David Farnokia, a navigation engineer at NASA's Jet Propulsion Laboratory, published a technical report. 3I/Atlas exhibited the first confirmed evidence of non-gravitational acceleration. Non-gravitational acceleration means the object is moving in a way that gravity alone cannot explain. Something is pushing it, and the numbers are specific. A radial acceleration, moving directly away from the sun, of 135 kilometers per day squared. To give you an idea of how big that push is, that acceleration would shift the comet's natural trajectory by roughly 10 times the radius of the Earth. Second, there's a transverse acceleration perpendicular to the direction of the sun, 60 kilometers per day squared. Now, if that sounds familiar, you might be thinking of Oumuamua, the first interstellar object detected back in 2017, which also showed non-gravitational acceleration, and whose case still divides the scientific community. The difference this time is that with 3I/Atlas, we have many more data points, many more observations, and the timing is perfect to truly study what's happening. Natural explanation, the rocket effect. So the obvious question is, what is causing this acceleration? There are 2 main hypotheses. Let's start with the natural one. The comet could be losing a huge amount of mass through violent sublimation of volatile ices. When the sun's heat evaporates the ice in a comet's core, the escaping gas jets outward at high speed. And by conservation of momentum, the comet is pushed in the opposite direction. It's like releasing a balloon without tying it. The gas escapes one way, and the balloon flies the other. But here's the problem. To generate this level of acceleration, Avi Loeb from Harvard calculated that 3I/Atlas would have to lose approximately 10% of its total mass during the single month it takes to cross perihelion. And if that were happening, we should be witnessing something spectacular. A massive cloud of gas surrounding the comet. Not just a little vapor, but at least 5.5 billion tons of gas, forming an enormous plume around the object. And here's the crucial part. We will be able to verify this. In November, when the comet reappears from behind the sun's glare, every telescope on the planet will be watching. Hubble, James Webb, and dozens of ground-based observatories. If we see that enormous gas cloud, case closed, it's violent sublimation, a natural explanation. But if we don't see it, technological hypothesis, a motor? Now, the second hypothesis. The acceleration could be the technological signature of an internal propulsion system. Before you think this sounds like science fiction, let me explain why some scientists are actually considering this possibility seriously. Avi Loeb from Harvard explains it like this. If 3I/Atlas were some sort of craft equipped with a propulsion system, then its perihelion, its closest approach to the sun, would be the perfect moment to execute a maneuver. If you want to change your trajectory efficiently, the best time is when you are traveling fastest near a star. At that point, even a small thrust can generate a massive change in velocity. That's basic orbital physics. And curiously, or perhaps not, the perfect moment for such a maneuver happened exactly when 3I/Atlas was hidden from Earth-based observation. A perfect solar conjunction, completely invisible to every telescope on the planet. Loeb is not saying that it is a spacecraft. He's saying that the data does not rule out that possibility yet. And there's precedent. Oumuamua, the first interstellar object discovered in 2017, also showed non-gravitational acceleration, but it had no visible tail, no gas emissions, no dust, nothing. That led some scientists to label it a dark comet. A comet without a visible tail. But as Loeb pointed out, calling it a dark comet is like a caveman insisting that an iPhone is just a rock. It ignores the obvious possibility of technology. The blue color anomaly, during the conjunction, only satellites equipped with coronagraphs, instruments designed to block the sun's direct light, could observe 3I/Atlas. Satellites like Stereo A, SOHO, and GOES 19 were among the few that could actually see it, and they all reported the same thing. The comet became dramatically brighter than expected. Researchers Kang Sang and Carl Badams noticed something strange. As 3I/Atlas approached the sun, its brightness increased much faster than in any ordinary comet. But brightness wasn't the most unusual part. The real anomaly was the color. 3I/Atlas turned blue, like the flame of burning gas, while the sun, right beside it, remained yellow. And this is extremely unusual. Comets are normally reddish, because sunlight reflects off dust particles in their tails, and their surfaces are far colder than the sun's. That difference in temperature tends to make them appear red or orange. The sun burns at around 5,500 degrees Celsius, while the surface of a comet like 3I/Atlas should be below freezing, more like a massive cosmic block of ice. So why is it glowing blue? Loeb added this to his growing list of unexplained characteristics. There are two possible explanations. First, the blue glow could come from ionized gas, specifically ionized carbon monoxide, CO, which can naturally produce that color in comets. Second, it could come from a heat or light source hotter than the sun, something internal like a motor. Both are technically possible, but only one could be verified when the comet reappears in December. The December test, December 19th, when 3I/Atlas reaches its closest approach to Earth. Every major observatory will be ready. Hubble, James Webb, and telescopes across the world will all be searching for one thing: the massive gas cloud that should exist if the comet lost 10% of its total mass during perihelion. If they detect that huge cloud of gas, then the answer is simple: a case of extreme sublimation, a natural phenomenon. But if they don't see it, or if the cloud turns out to be far smaller than expected, then we have a serious problem. Because that would mean the acceleration didn't come from escaping gas. It came from something else. Something we do not yet understand. The blue light enigma revisited. The strange blue light remains one of the greatest mysteries. If the color truly came from ionized gas, we should already be seeing specific spectral lines, fingerprints in the light that confirm the presence of certain molecules. But so far, those lines have not matched expectations. The readings don't fit any known model for a natural comet. Instead, they suggest an emission spectrum, a type of control light. That's why scientists around the world are eagerly waiting for December, because this is the test that will decide whether 3I/Atlas is just an icy traveler or something more. The role of the sun. And there's another layer to this mystery. During its solar conjunction, 3I/Atlas was in perfect alignment with the sun, completely invisible from Earth for several days. That means, for a brief moment, the comet was in a region where communication, observation, and even light from our instruments were blocked, a place of silence. If there were ever a moment for a maneuver, for a deliberate change in direction, this would have been it. And as 3I/Atlas emerges from behind the sun, it's not just scientists who are watching, it's the entire world. The December observation, in mid-December, as the comet moves away from the sun, all the data from Hubble, James Webb, and the ground observatories will begin to arrive. The question is simple: will we see that gas plume or not? If it's there, then the story ends. The acceleration was caused by violent sublimation, a natural process. But if it's missing, if there's no plume, or if it's only a faint trace, then we are left with one conclusion. Something other than gas pushed 3I/Atlas. Something else gave it motion. Conclusions. The most likely explanation still remains that 3I/Atlas is a natural comet with very unusual characteristics. Most scientists agree on that. Tom Statler from NASA said it best. It looks like a comet. It acts like a comet. It's probably a comet. But Avi Loeb insists on something important. that we should not ignore anomalies just because we can't explain them elegantly. The non-gravitational acceleration is real. The blue color is real. The extreme brightness is real. And in science, when data doesn't match our expectations, we have two options. Either assume the data is wrong, or accept that our understanding is incomplete. December will bring the answer, or at least bring us closer to it. Whatever 3I/Atlas turns out to be, a natural comet or something technological, it's already teaching us something profound, that the universe still holds secrets, that not everything has been discovered, that there are still moments when the cosmos whispers truths we're not yet ready to understand. 3I/Atlas is one of those whispers. Subscribe to the Atlas frequency if you want to follow this story as it unfolds, because something tells me this is only the beginning. You're watching the Atlas frequency, where the universe remembers itself,